NASA, on their pioneering decade-long mission to explore the Pluto system and the Kuiper Belt billions of miles from Earth, launched a little robotic spacecraft to show us the first glimpse of mysterious Pluto, the distant icy world at the very edge of our solar system. Pluto, orbiting what we call the Kuiper Belt, hosts thousands of other objects orbiting alongside it. The region is littered, just like the asteroid belt, with celestial bodies. At first, Pluto seemed like just another frozen, forgotten rock, a distant relic at the edge of our solar system. But the truth is far more extraordinary than anyone ever imagined. Beneath Pluto's icy, desolate surface, there's a secret so huge it could change everything we thought we knew about the cosmos. Imagine the shock when scientists discovered that Pluto isn't lifeless after all. It has underground volcanic activity and even the building blocks of life hidden from us all this time. This raises profound questions about the search for life beyond Earth. Could the cold, distant world of Pluto hold the key to understanding life in the most unexpected places? Get ready, because what's been hiding on Pluto for all these years will blow your mind. For years, Pluto was considered a desolate, frozen world on the fringe of our solar system. It seemed too distant and too cold to have any significant features, much less something as unexpected as life. But that perception is quickly changing, thanks to groundbreaking discoveries made by the James Webb Space Telescope. The James Webb Space Telescope is upsetting the apple cart. Suddenly, we realized we may have to rewrite all the textbooks about the beginning of the universe. Initially, scientists were puzzled by unusual data, a signal hinting at more than just a frozen shell. As the telescope turned its infrared lenses toward Pluto, it revealed something incredible, an underground ocean. This is a game-changer for a planet so far from the Sun, with surface temperatures that can dip as low as -375 degrees Fahrenheit. How could water stay liquid? The answer lies in something surprising: Pluto's interaction with its moon, Charon. Through a process known as tidal heating, the gravitational pull between Pluto and Charon generates enough internal heat to keep Pluto's subsurface ocean from freezing solid. A hidden liquid ocean beneath a frozen surface, something we never expected to find on a planet so distant. But wait, there's more. The James Webb Space Telescope didn't stop there. As it examined Pluto's atmosphere, scientists were stunned to find organic molecules, the building blocks of life. Organic compounds aren't just signs of chemical processes, they are the very ingredients that could form life itself. Imagine this: Pluto, once considered a lifeless ice ball, might actually be hiding some of the most fundamental elements needed for life. These organic molecules suggest that Pluto's atmosphere could be undergoing complex chemical reactions, much like those occurring on Earth, possibly opening the door to the unimaginable, life on Pluto, or at least the potential for it. This raises even more questions. If Pluto can harbor liquid water and organic molecules, could there be life living deep beneath its surface? It's a possibility that has scientists buzzing, making us rethink what makes a planet habitable. The more we learn, the more we realize Pluto isn't the frozen wasteland we once thought. It's a dynamic world with secrets hidden beneath its icy shell, secrets that could change our entire understanding of life beyond Earth. These discoveries about Pluto aren't just interesting, they are game-changing. For years, we believed that life had to depend on the warmth of the sun. After all, here on Earth, the sun fuels everything: plants grow, animals thrive, and life exists because of it. But what if life could survive without sunlight? What if it could thrive in places so distant and cold that the sun is just a faint dot in the sky? This idea isn't as far-fetched as it sounds. On Earth, in the deepest parts of the ocean, there are entire ecosystems living in complete darkness. Creatures like fish, bacteria, and giant tube worms survive without a single ray of sunlight, relying instead on the heat and chemicals released by hydrothermal vents deep in the ocean floor. These environments are far from the sun, yet life not only survives but flourishes. This is exactly the kind of environment Pluto may offer beneath its icy surface. Pluto, we now know, is not the cold, lifeless world we once thought. It has a hidden subsurface ocean, kept liquid by a process called tidal heating. This is where Pluto gets its energy, through a gravitational interaction with its moon, Charon. As Pluto and Charon dance around each other, they pull and stretch, creating friction that generates heat inside Pluto. This heat is enough to keep its underground ocean from freezing solid, despite the surface being a frigid -375 degrees Fahrenheit. It's a fascinating example of how life could exist even without the warmth of a star. But there's more. The James Webb Space Telescope also detected organic molecules in Pluto's atmosphere. These are the building blocks of life, the same compounds found in environments on Earth that are rich in life. The presence of these molecules on Pluto raises an important question: could there be life, albeit microbial, thriving in that hidden ocean? While we don't have definitive proof yet, it's possible. The conditions needed for life, organic chemistry, water, and heat, are all there. Of course, many people wonder if Pluto has oxygen, and the answer is no. It doesn't have oxygen like we do on Earth. Its atmosphere is mostly nitrogen, with traces of methane and carbon monoxide. But life on Earth has evolved in some of the most extreme conditions, in places where oxygen isn't present. Organisms living deep in our oceans, in volcanic vents, and other harsh environments don't need oxygen to survive. The same might be true for any potential life on Pluto. So, how powerful is Pluto? It might not have the size or mass of a planet like Earth, but in its own way, Pluto is incredibly powerful. It's not just an icy rock sitting at the edge of the solar system. Pluto is alive with potential. Hidden beneath its surface, there's an ocean, a dynamic atmosphere, and evidence of complex geological activity like cryovolcanism. This tells us that Pluto isn't as dead as we thought. It has the kind of geological processes that can change the surface and sustain a hidden world beneath. These findings are forcing us to rethink what we know about the habitability of distant worlds. If Pluto, once thought to be a desolate ice ball, can support the conditions needed for life, then we must ask ourselves, what else might be out there in the far reaches of space, waiting to surprise us? The main challenge in exploring Pluto was simply accessing meaningful data from such a distant and isolated world. At nearly 4.7 billion miles from Earth, Pluto was a target too far for traditional methods of space exploration. The extreme cold and lack of sunlight meant that Pluto couldn't be studied with conventional telescopes, limiting our understanding to only surface-level observations. This was a critical challenge because, without clear data, any hypothesis about what might lie beneath its icy exterior would remain just that, a hypothesis. The stakes were immense. Pluto's status as a dwarf planet on the fringe of the solar system was a symbol of our ignorance about distant worlds. The more we learned about Pluto, the more we realized that it could hold valuable answers about how planets evolve, and how to rethink what is necessary for a world to support life. It became clear that Pluto's mysteries, if unlocked, could redefine the limits of what we consider habitable, not just in our solar system, but across the cosmos. To overcome these challenges, scientists turned to the James Webb Space Telescope to provide a solution. Webb's incredible infrared capabilities allowed us to peer beneath Pluto's dense atmosphere, revealing new details about its surface and atmosphere that were previously out of reach. Instead of just relying on flybys or surface images, Webb provided deeper, more precise data, revealing things like organic molecules in Pluto's atmosphere, something that was previously overlooked. This was a key breakthrough because it showed that Pluto, far from being lifeless, has the building blocks of life, even in its cold, distant environment. Moreover, tidal heating, the heat generated by the gravitational pull between Pluto and its moon Charon, was identified as the energy source keeping Pluto's subsurface ocean liquid. This was the game changer. The heat from tidal forces, rather than the sun, sustains the ocean and could provide a suitable environment for microbial life. The presence of organic molecules suggests that the conditions for life, at least in microbial form, could be present on Pluto, something we never imagined when the planet was first discovered. What does this mean for the future? The next steps are clear: more missions, more data, and continuing to explore the boundaries of what we consider habitable. Pluto may be far from the Sun, but the very processes that support life on Earth, organic molecules, water, and energy sources, are found in places we never thought possible. The discoveries here could have far-reaching implications, not just for Pluto, but for other icy moons and distant exoplanets, pushing us to rethink where life might exist in the universe. In the end, while the challenges of exploring such a far-off world were immense, the solutions we've found through advanced technology like Webb and the continued exploration of our solar system are expanding the possibilities for what we know about life and our place in the universe. As we look out across the vast, seemingly endless expanse of space, it's hard not to feel both small and significant at the same time. We've learned that Pluto, a tiny speck at the edge of our solar system, is far more than we ever imagined. Beneath its icy surface, hidden away for centuries, lies an ocean warm enough to sustain life, shaped by forces that mirror the very processes that keep our own world alive. It's a reminder that the universe is full of secrets waiting to be discovered, and even the most distant, forgotten places can hold answers to questions we've only just begun to ask. What we've uncovered on Pluto isn't just a scientific breakthrough, it's a profound reminder of the beauty and mystery that surrounds us. We've always looked to the stars for answers, hoping to understand the nature of life, the universe, and our place within it. Now, we know that even in the most extreme conditions, life can find a way to survive. If there's life on Pluto, or even the potential for it, it opens up a universe of possibilities for the search for life elsewhere. This discovery on Pluto invites us to wonder, what else is out there? What other icy moons, distant planets, or far-off galaxies are hiding secrets, just waiting to be revealed? Our exploration of the cosmos is just beginning, and what we've learned from Pluto shows us that the boundaries of possibility are far broader than we ever imagined. As we continue to reach beyond the stars, let us be reminded of one simple truth: the universe is vast, mysterious, and brimming with potential. The wonders we've discovered are only the beginning, and the journey ahead will reveal even more extraordinary truths. Every discovery, every new question, leads us closer to understanding the profound beauty and potential of the cosmos, and the possibility that, in the coldest, most distant corners of space, we may not be alone. So, as we look to the stars and the many worlds still waiting to be explored, we are reminded that the universe is not just out there, it is within us all. Let this discovery inspire us to keep seeking, keep wondering, and keep believing that the answers we seek are out there, just waiting to be found.